Good day, class. Welcome to our very first lecture in Geotechnical Engineering 1. So, our first chapter is the soil formation, and under this, we have the contents such as the soil and its constituents, the weathering of rocks and types of soils, the description and identification of soil using Visual Manual Procedure or ASTMD 2488. And lastly is the mineralogy of soil solids. So in this video, we will be discussing the first two contents of this chapter, which is the soil and its constituents and the weathering of rocks and types of soils. So, soil and its constituents. So, for engineering purposes, the soil is defined as the uncemented aggregate of mineral grains and decayed organic matter. So, these first two is the solid particles of the soil, and in between those solid particles, it is either filled up with water or air. So the in the next chapter, we will be discussing about the weight volume relationships of soil, and we will encounter different circumstances where all voids are filled with water and all voids are filled with air. So we have those various circumstances. And next is the weathering of rocks and types of soils. So first, let us recall that weathering is the process of breaking down of rocks by mechanical and chemical processes into smaller pieces. And weathering may be mechanical or chemical. So let us also recall that in mechanical weathering, the large rocks are broken down into smaller pieces without any change in chemical composition. So this may be caused by the expansion and contraction of rocks from the continuous gain and loss of heat and the seepage of water. That is another factor that can cause mechanical weathering. And there are also other physical agents that help disintegrate rocks. So this may be caused by glacier ice, wind, running water, and ocean waves. So on the other hand, we have chemical weathering. So in this type of weathering, the rock minerals are transformed into new minerals by chemical reaction. So this can be caused by the carbonic acid, which is formed by the carbon dioxide and water. So after the rocks are weathered, we have these so-called weathering products. So these weathering products may be residual or transported. So when we say residual, the products of weathering stays in the same place. So we call that residual soils. So according to Braham Das, an important characteristic of residual soil is the gradation of particle size. So fine-grained soils is found at the surface, and the grain size changes with depth. So, at greater depths, you will find angular rock fragments. So, on the other hand, we have transported soils. So, transported soils may be classified depending on their mode of transportation and deposition. So, these are the soils. Once again, transported soils are the soils that are moved by into other places by ice, water, wind, and gravity. So, we can classify these soils as such. So first we have the glacial soils, alluvial soils, lacustrine soils, marine soils, aeolian soils, and colluvial soils. So first, what are the glacial soils? So this soil is formed by the transportation and deposition of glaciers. So we have the following terms. First is drift. So, drift is a general term usually applied to the deposits laid down by glaciers. So, the physical characteristics, the unstratified deposits laid down by melting glaciers are referred to as till. So, we also have moraines, which are the landforms that develop from the deposits of till, and moraines may be terminal, recessional, or ground. So, a terminal moraine is a ridge of till that marks a maximum limit of glaciers advance. So, we also have the recessional moraines, which are ridges of till developed behind the terminal moraine at varying distances apart. So, lastly, the till deposited by the glacier between moraines is referred to as ground moraine. So, ground moraines constitute large areas of the central United States and are also called till plains. So, lastly, we have outwash. So, these are the sand, silt, and gravel that are carried by the melting water from the front of a glacier. So, next is we have the alluvial soils. So, alluvial soils are transported by running water and deposited along streams. So, we have two major categories of alluvial soils, which are the braided streams and minder belt deposits. So, the deposits from braided streams are high grade, can be described by the follow several characteristics. But first, let us define braided streams. So, braided streams are high gradient, rapidly flowing streams that are highly erosive and can carry large amounts of sediments. So, because of the high bed load, a minor change in the velocity of flow will cause sediments to deposit. So, in this process, these streams may build up a complex tangle of converging and diverging channels separated by sandbars and islands. So, we have the several characteristics of braided streams deposits. So for clarification, these are the characteristics of braided stream deposits, not the braided streams itself. So first is the grain size, usually range from gravel to silt. So generally, clay size particles are not found in braided stream deposits. So the second one is, although the grain size varies widely, the soil in a given pocket or lens is uniform. And last, the last one is, at any given depth, the void ratio and the unit weight may vary over a wide range within a lateral distance of only a few meters. So, for the second category of alluvial soils, we have the minder belt deposits. So, the term minder is derived from the Greek word meandros. So, this is after the Meandros River in Asia. So, and that river is famous for its winding course. So, the valley floor in which a river meanders is referred to as the Minder Belt. So, in a meandering river, the soil from the bank is continually eroded from the points where it is concave in shape and is deposited at points where the bank is convex. So we call these deposits as point bar deposits, and they usually consist of sand and silt particles. So sometimes, during the process of erosion and deposition, the water abandons a minder and cuts a shorter path. So if that abandoned minder is filled with water, we call that as oxbow lake. So during floods, rivers overflow low-lying areas. So the sand and silt particles carried by the river are deposited along the banks to form ridges known as natural levees. Next is we have the lacustrine soils. So lacustrine soils are formed by deposition in quiet lakes. So this is because the water from rivers and springs flow into lakes, and these streams carry a large amount of suspended solids. So next is we have the colluvial soils. Colluvial soils are formed by the movement of soil from its original place by gravity. So an example of this is a landslide. And next we have the marine soils. So they are formed by the deposition in the seas. So lastly, we have aeolian soils. So aeolian soils are transported and deposited by wind. So wind is a major transporting agent in the formation of soil deposits. So first we have the dunes. So these are formed when the sand is blown over. So this is very common in deserts. So in dunes we have the crest. So and beyond that crest, the sand particles will roll down the slope. So because of this, it tends to form a compact sand deposit on the windward side and a rather loose deposit on the leeward side. So here are some typical properties of dune sand. So first is the uniform grain size distribution. So this can be attributed to the sorting action of wind. So next is the general grain size decreases from the distant source. So this is because the wind carries the small particles farther than the large ones. And lastly, the relative density on the windward side can be as high as 50% to 65%. And while on the leeward side, it is about 0 to 15%. So next we have is the Loess. So a Loess is an aeolian deposit consisting of silt and silt-sized particles. So its grain size distribution is rather uniform. And lastly, we have volcanic ash. So also referred to as volcanic dust. So this is also classified as wind transported soil. So the volcanic ash is a lightweight sand or sandy gravel. So and the decomposition of this ash results in highly plastic and compressible clays. So the grain sizes of volcanic ash varies between 0.25 to 4 mm, while the volcanic dust, the grain size is less than 0.25 mm. So we also have some special terms used to describe soils. First is we have the boulder clay. So this is an unstratified mixture of clay and rock fragments of all sizes. Next we have the dispersive clay. So this is a clay that is easily erodible under low velocity water. Next we have the reactive clay, which is an expansive clay that swells when in contact with water. So we have the calcareous soil. So this is the soil that contains calcium carbonate Next is we have the fat clay. So it is a very highly plastic clay. The loam, which is a mixture of sand, silt, and clay, used as topsoil. The conglomerate, which is a cemented sand and gravel. The hard pan, which is a very dense soil layer, often cemented, that is difficult to excavate. Next is we have the varved clay, which is a thin alternating layers of silts and fat clays of glacial origin. And lastly, we have the laterite, which is a red-colored residual soils in the tropics. So, lastly, even though na under the classification of transported soils, let us also discuss the organic soils. So, organic soils are usually found in low-lying areas where water table is near or above the ground surface. So, because of this, the natural moisture content may range from 200% to 300%. And this also helps in the growth of aquatic plants. So when these aquatic plants decompose, so more organic soil is formed. So next is organic soils are highly compressible. And last, so it is shown by laboratory tests that a large amount of settlement is driven from secondary consolidation. So that's it for the first two contents of the first chapter. And the next video we will be discussing about the description and identification of soil using the visual manual procedure. So these are the references I have used in the preparation of this video. So you may use this for your further reading. And as for your assignment, you have to take down your notes on this video. So that is your assignment number 1. So as well as for the upcoming videos. So that is your assignment in your notebook. So further instructions will be given to you via the learning management systems. Thank you guys.